Hey, good evening, meteorologist Zach Gilday here with Chief Meteorologist Dan Scott. And we are doing this Facebook Live here. It's Sunday, 11:02 p.m., so it's a live update, and we have severe weather to talk about. And the question is, will we get these storms? Because there are some things that are in question. The instability is in question. The timing seems to be a little bit earlier than what we were kind of talking about a couple days ago. And we can see Dan joining remotely. Um, yeah, so I've been looking at the models all day, Dan, and I do think that the trend is, daybreak Tuesday morning. It was going to be a morning deal, and I think I should be out of here by around 1 p.m.
Yeah, I can't disagree with that. I couldn't agree more. I think that this line comes through. It's going to be pretty quick. I've been seeing a lot of let's just say thunderstorm activity that's really going to cut down on the instability. The instability is going to be a lot less. I don't even see a whole lot of surface-based cape, and you can run us through all that stuff, with the weather graphics. But I would say that things are definitely trending down, and I wouldn't be surprised if the Storm Prediction Center, at least for our area, kind of takes that down a little bit. But again, you can't let down your guard because it is such a strong storm, and there's so much dynamics, meaning the wind shear is off the charts, and we can show some of that. But you've got to have the instability in order to have thunderstorms, and that's something that we could be lacking, especially with those high resolution models showing the latest.
Yeah, and I did make this graphic earlier this evening. It's a new one, and we haven't used it in a while. It's the severe storm timing, so we can see it right here. We've got the yellow shade that is 6 a.m. to 9 a.m. So the storm start time. So I do think it's going to be around daybreak in our western counties, eastern Oklahoma, continuing to move pretty straight north to south line. Interstate 49, 7, 8 a.m., 11 a.m. So we're used to having these storms in the afternoon, evening, and especially overnight here in Northwest Arkansas. This is going to be a little bit different. It's going to be in the morning. So commute to work, commute to school, this could be impacted with this line. And we've been talking about the severe storm threat maybe decreasing a little bit. Well, I can tell you what, the rain, that is not going to be decreasing. And you don't want to be out in these heavy downpours, especially, during rush hour. That could be a serious deal. And then I think all this should be out of here. We can see leaving 1 p.m. at the very latest. So it's looking like a morning event. And I was looking at some models showing some afternoon clearing. So the models are pretty aligned and showing that morning arrival time.
Now, what do you think about this? Is something I've been looking at, Zach, and I wanted to kind of get your opinion. It appears that as the low comes overhead, we may get a little bit of low topped thunderstorms that would have a tremendous amount of shear underneath the low. And there still is some instability that kind of works its way back into the area after this line. That.
Yeah. If the low tracks close to us, couldn't that be a trigger for tornadoes?
What we call cold core. Yeah, like a cold core setup. In fact, Casey's right on top of it. He talks about cold core low. So when you got like 25 degrees Celsius, minus 25 degrees Celsius at 500 millibars, which we know this system's cold because on the backside of the system, you've got a little bit of wraparound that could bring precipitation that might squeeze out even a little bit of some wintry precipitation, such as some snow that's possible in the early morning hours on Wednesday as the system moves overhead. So everything's quiet right now. So Zach, you got to know that this timing on here, as he knows, but just for everybody else that's watching, this is in the morning on Tuesday, not tomorrow morning. Tomorrow morning won't be a problem at all. Let's take us through the risks if you can, Zach. The marginal that's off to our west and the slight as well. So here, Edward's saying marginal is higher than slight. No, it's not. Marginal is lower than slight. Go to the day one outlook first, Zach. Day one was a slight risk in southwest Oklahoma. Now that is completely gone. But there were some funnel clouds that were reported in southwest Oklahoma. Granted, they had a little more instability. So this is the day one convective outlook. And then you go to day two, and you'll see it become a slight risk over Oklahoma. And the marginal threat kind of clips our area. Now, this makes sense because remember, this ends at another one of these risks where we're going to be in between the two. This ends at 6 a.m. Tuesday morning. And that's why that green shaded area is right on there. And if you go to the day three convective outlook without moving it, you'll notice that we're on the western fringe of that risk. And that starts at 6 a.m. and goes until 6 a.m. Wednesday, which, by the way, it's going to be over by then. This is a fast moving system. So, Zach, you need to take us through the timing with the future tracks. Let's do that because I know people want to see that. No, we're not in a moderate risk. Nope. So this is the future track, and this is the graph, right?
Yeah. So I think this model is handling it the best. And here's Monday noontime. So we can see the south flow. Tomorrow is going to be a windy day, and I do think cloud cover is going to win out. We can see here 6 p.m. So Monday is mainly dry. I think maybe some drizzle out ahead of this big storm system. That wouldn't be out of question because the moisture is really going to be pumping in tomorrow. Still, it's right now it's still quite dry, but tomorrow that's when the moisture is going to work its way back in. Here's 2 a.m. So we've got some storms forming off to our west, and I wouldn't be surprised if we had some activity going on Monday nights before this line comes in, and that could decrease the instability even more. Here's when the line comes in. So
someone asked too if it's balanced. I will say that what we have to watch out for this line is isn't that line on the future track look balanced? It does, and we know that the 0 to 3 kilometer shear vector will definitely, or 0 to kilometer bulk shear will be over 30 knots with this type of system. There's absolutely no doubt about that. The question is do we have 0 to 3 kilometer cape? And that's a question that I think we won't be realizing, honestly. We'll definitely see some, mixed layer cape. We'll see some mostly unstable cape. But as far as surface based, it's going to be tough. However, with this being a line, we could still see that potential for QLCS spin ups along it. I still think it's possible, but it's not set in stone either. So yeah, advance a little bit more forward, Zach. So it's a pretty stout line, and there have been events when stuff like this has come through in the morning hours. This is not unusual, but it's not, extremely common either. But it is not unusual. Now here's the low when it kind of churns over us, and I don't know how much instability there's going to be on that. It looks like a pretty drawing wind on the graph, but if you look at the HRRR, you'll notice a little bit more storm activity. And then there's the wraparound snow that happens. Pretty intense dynamic system. We know this. We know this system is extremely dynamic.
yeah, so here's the HRRR. It's 1 p.m. Monday.
I don't know about that, Edward. Maybe not in Bentonville, but there was definitely rain in Fayetteville. And I was talking with a friend. He was driving back to Kansas. He was encountering rain, pretty steady rain too. So it might not be everywhere, but that's why we didn't go 100% for the chance of rain, Edward. We only went, what did you go, 30?
I went
40?
30 Northwest Arkansas, 60 for River Valley.
Yeah. So that's a good question, Tiffany. If we are on the air and we're doing wall-to-wall coverage, meaning constant severe weather coverage, we are on what's called KLRC. KLRC is 90.9. It's the Christian radio station. Also, too, sometimes Cumulus radio stations takes us. Josh is like, no more snow. Hey. What do you think about those impacts with the snow? I don't think they're very much because we're so far above freezing when it happens.
No, I'm not expecting accumulation. I'm
Yeah.
not expecting impacts with that. But I wouldn't be surprised if we saw some flakes falling.
So, all right. So 7 a.m. Here comes the line. It's more balanced. Well, go back and kind of step through it if you can, time by time. my, my wife just texted me and says I got to do some stuff in the background. I know this is a work in progress. It's a mess behind me. We do. We have a lot of cords. I have a lot of things, but you can dream, babe. We'll do some cleaning up here. You can dream that this will be a cleaner workspace. Yeah, I will. I'll take care of that. I got some plans here to make that look a lot better.
Yeah, here's 2 a.m. Tuesday, so Monday nights, and this is showing some activity, and that would sap the atmosphere of instability. That rainfall will cool down the atmosphere. Here's 5 a.m. Lines forming. That was pretty intense. That line coming in, daybreak Tuesday. Not a
Okay,
time
so
you
let,
want line to come.
let's step through it time by time here, just like every hour, so you can kind of see how this line evolves.
Okay. Yeah. Here's 7.
Just kind of slowly advance it. Yeah. So at that point, you notice there's some line breaks. So, we're going to have to watch for that QLCS potential. Yeah, it definitely could be. So this is what I was talking about. On the HRRR, you're going to notice a few thunderstorms that are going to be possible in the afternoon underneath that low. And sometimes that extra spin in the atmosphere can cause some issues. So go forward a little bit more.
As far as it goes.
Okay. Is that yeah, I guess that is as far as it goes. It goes a little bit farther. So start looking at some of those parameters. Oh, you got to see what we did too. We did some brand new okay, so Bethany, the time if we do see tornado potential, it would be, well, we had the timing on there when that line comes initially through. Now it's going to be, as someone mentioned on social media, and they said, oh, whatever, it's just going to be a quick line that moves through and a few spin ups along the leading edge of the line. Absolutely. It's going to be a fairly thin line. It's going to hit hard and it's going to be quick and then it's going to be out of here. So it doesn't last all day. But Zach, yeah, you got a lot of stuff.
Yeah, I'll load some up.
That you can load it. You could just go into the category severe weather parameters, and you should be able to pull them up really fast.
All right, stand by.
Yeah, tomorrow is going to be very calm. Looking forward to tomorrow evening. Oh yeah, Alex Hall, we got a storm spotter meeting. You're right. All those that are on our storm spotter team, appreciate each and every one of you, and got some exciting news to add to you guys. So that's pretty cool. Yeah, just to let you know, it's going to be between, I'm thinking 8 a.m. to 11 a.m. What do you think, Zach, on timing?
Yeah, I think 8 a.m. to 11 a.m. is the best case for the, that's what I'm thinking.
Nope, that is a twister thing, or twisters, Edward. Twisters. You want me to pull up some stuff, or are you getting it?
It was locking up on me, but I just got a few things. So I can show you Cape.
Yeah, show us Cape, and we've got it with the HRRR, right? Don't we?
Yeah, I got it right there.
So first of all, I love the new color scale. Zach helped develop it. So did Peyton, and it just looks so much better than it did before. So look at that, how that instability just goes away. And you can see a little bit there, but not much. Now, look at these SIG-TOR parameters, Zach. See, there's still some instability that comes overhead at about 5 o'clock. So Kiara has a question. If we were to get tornadoes, hey, look at that profile picture. I recognize that.
Hey,
Hey, it's a KNWA set. So they would be, I mean, they would be weaker. They'd be EF0, EF1 if we have them. But remember, all tornadoes are definitely dangerous. So here's a look at the significant tornado parameter. This is Monday night, and if you advance it, Zach, it just completely goes away. And there's good reason for that. It's because of the thunderstorm activity kills the instability. So I honestly think, you want to know where I think the tornado potential is the greatest? New Orleans on Fat Tuesday in the evening. Could be a dangerous night.
yeah, definitely. We can see it down there. Louisiana. You've got some more products or different models.
Yeah.
We can look at the NAM 3-kilometer Cape. Because I think Cape is the thing that's in question here.
Well, this isn't 3-kilometer Cape. This is the 3-kilometer model.
Yeah.
Sorry, but I know what you mean.
Yeah.
Cape is the big underlying question.
Got a little more during the afternoon hours.
That's the stuff that I was talking about, that little development of
So
these cells.
there could be some surprises during the afternoon tomorrow.
Okay, so for instance, the only thing though is I just don't think the profile is going to line up for us.
Yeah. Okay, we can look at energy helicity index. It's probably not even that high because there's not enough instability. Just goes away.
Yeah, it does. Do you mean surprises in a good way? Yeah, as in, did you say surprises, Zach, or did I?
Yeah, I said surprises, and I mean we're talking about those. The low coming overhead that could increase the tornado potential Tuesday afternoon. But yeah. So Cape, I think that's in question. And I did see a question from Edward. He was talking. He wants us to explain the instability, and Dan's got a sounding up there, so we can.
Yeah, I can. I'll do that real quick. So, and then we'll go through some timing, and then you've got the timing for the hour by hour. So let's do 0 to 3 kilometer above ground level Cape. So this is what's important for QLCS tornadoes. So this is 0 to 3, and we're doing a wider view, so you can see that, yeah, the 0 to 3 kilometer Cape, it's up there. So there probably will be some tornadoes that are in Oklahoma. So if I click on this, and you can see the wind profile. So a sounding is essentially the way that the temperature and the dew point either increases in temperature or decreases in temperature with height. And then you've got the wind profile, which is the wind speed and wind direction. So those are the four things that a sounding has, which is called a skew T log P. Number one, you're going to notice that this right here, everything that's to the right of this temperature is Cape, meaning that if you were in a hot air balloon, you would be warmer than its surrounding environment, so you would just continue to rise. That's Cape. And then essentially, when you aren't warmer than your surrounding environment, hot air rises. Well, if you're cooler, then you're going to sink. And so everything that's above to the right of this red line, you are rising. And you'll notice here there is some instability in the 0 to 3 kilometer. You can see it says right here 151. I'm going to do this, Zach, real quick, so people can see this a little bit bigger. It's a little bit bigger. So 151 is the 3 kilometer cape. So that means that's the amount of instability in this lowest level. Why is that important? Because you have QLCS tornado potential. Oh, Zach, should we take them through the QLCS tornado potential graphic that I made?
Yeah, I'm gonna load it up.
In just a second, but I want to show you this, that this actually goes down big time as it moves in. So first of all, anything that's under 50 is not sufficient. Now you see that cape ramp back up, Zach?
Yeah, the sun comes out after that line comes through, and
Yeah,
that's what the models show. Pretty much every one shows the clearing.
it does, but now look at the wind profile. Absolute trash.
Mm,
That is not going to be supportive of tornado potential.
yeah.
Look at the shear just goes down to nothing. So if we go back to this, even with that instability, we go here to, let's see here, 43 hours. And then I go to the 0 to 3 kilometer storm relative velocity. Yeah, maybe not. Here we go. Watch this just go down to nothing. Ready? So here's Tuesday. There's Tuesday morning. It's off the charts, and then it's just gone when that new instability builds back in. So, I mean, honestly, I'm thinking we'll get some thunderstorms. I'd be surprised if we had QLCS tornadoes. I just would. Judging on everything that I'm seeing and the lack of instability. Now, granted, it could always be warmer. It could be a little less stormy, and then that would lead to more storms. But man, these helicity charts are off the scale. Look at that wind profile. 610. Look at the sounding. The photograph is insane. It's a beautiful photograph in terms of tornado potential. I mean, it's a very favorable. I say beautiful because I'm doing a lot of research on critical angle and tornado potential, and this is a very highly favored profile for a storm that's moving east northeast. However, the atmospheric thermodynamics is garbage. So this is a case where we have instability and shear not lining up, which you have to have both in order to have severe weather potential.
Yeah, we do. And this system is a beast. And just to show you it, I can show you the energy coming in.
Yeah, you should. Yeah, show us that stuff.
And people are talking about, I think people were saying thunder snow out there in California.
Yeah, I believe that. My mom said it was so windy she had to stop after 4 holes of golf, which that tells you it's windy. By the way, too, another interesting thing I noticed is the surface low and upper low will be stacked. What that means is when it's stacked, it's starting to wind down. Friction's taking over, and your storm has already gone through its most intense cycle. Yeah, take us through some water vapor.
All right. So, do that. Here it is. So we've got, where's Dan? So we've got, that big storm system. You can see it in the water vapor that spin in the atmosphere. That's the storm impacting California right now. And check out all of that.
Oh, check out that new vorticity color scale too.
Looks pretty good, huh?
Yeah, we made that just to let you know. We adjusted that, and the reason we did is because it just looked like precipitation. Now look at all that rising motion, all those little blue blobs that are on the screen. All those, what they're going to do is create a tremendous amount of lift. And go back just a little bit to like 7 a.m., Zach. Yeah, it goes pretty quick because you have the GF. There you go. you can't tell me that that's not going to form thunderstorms. There's going to be storms all over the place. There's just so much rising motion, and there's no sin. So this is just going to just blow up everywhere.
Yeah, and that energy, that's top of the scale. That spin, those whites, the light blues, that
Yeah,
serious energy coming in.
serious energy. We adjusted the scale too. When it's white, it's as strong as it can get.
Then we have that northwest flow. It's going to be cooling down behind that system. And yeah, here's a beach track.
Okay, here's the high resolution rapid refresh model. I mean, there's no doubt we're going to see rain, widespread rain, thunderstorms, heavy rain, downpours. They last maybe about an hour, and then there'll be that stratiform rain that the models don't show or pick up on. But that right there, those could be hailers. I don't think they're tornadic. Look at the winds out of the southwest. You see that?
Yeah.
Yeah, that just doesn't favor tornado potential. There's another system on Friday, but I noticed that like doesn't even look like it's going to rain now.
Yeah, that's definitely weekend. It is kind of looking more like Saturday morning now.
Mm-hmm.
Not too worried about that. But yeah, here's the day 3. Slight risk. And here's rainfall. So I do think flooding, I think that's going to be a factor that we have to talk about here.
You do?
Potentially.
I kind of have my doubts on that. And there's two reasons. Number one, we've been extremely dry. We really haven't had a whole lot of rain. I know the ground is hard, so you have quick rain in a short amount of time, but this line's going to be moving so quick.
Yeah.
Yeah, I think there will be an impressive shelf cloud, Brendan. I do think that's definitely a good possibility along the leading edge, and it's coming in around sunrise or a little bit after. But here's the thing: the line's quick. There might be stratiform rain behind it, but I think the flooding threat is more focused to the east when the storm really starts to continue to crank up and that stratiform line continues to develop. But I mean, obviously, you probably went 100% for the chance of rain, right? Tuesday.
Yeah. I mean, some of the models had some pretty heavy rain coming in before that line
Yeah, I
in,
could believe that.
in our southern counties. But yeah, the short range models do not really have that. So yeah, there's the Cape. But let's look at this. I think half inch to maybe up to 1.5 inches. But locally, I do think that we could see some areas, couple, maybe several inches of rain. But yeah, the models. Yeah, looking at them now, they've kind of backed off on the crazy rainfall totals.
Yeah. Did you know that it's Severe Weather Awareness Week too this week?
Oh, okay, yeah. It was today, day 1.
Today, tomorrow's day one. Today was just preparing for it, like telling you the different topics and stuff like that.
Oh yeah.
Yeah, I'm sure some meteorologist said everything's always the worst that it's ever going to be. Every single time, never fails. It's always the worst possible in the forecast. 2011 was an exceptional year. Do I think it's going to be active? Yes. Do I want to compare it to another year? No. I think people need to stop doing that. I think that's driving a lot of people to have anxiety. And I saw a good post on there too about that. It said, just because this system looks similar to what happened with another system, such as an analog, that does not necessarily guarantee the same outcome that you had when you had the same system that looked like it. So, um, does that make sense, Zach?
Yeah.
If you're comparing this storm to another storm or the pattern to another year, you know, who knows? But I'm sure, what is someone going to say? It's not going to be a big tornado year. That's not going to get the interaction. That's not going to get any comments on social media. if you say, it's just going to be an average tornado year. Do I think it's going to be active? Yes, because it's La Nina. But you know what? Our system that came through today, Zach, last night into this morning, that killed all of our moisture return. In fact, you should show dew points.
Yeah, we'll do that.
Let's do that. Yeah. It really isn't it's not a good habit to get into, Edward. I like that profile picture too. But it's not a good habit, and we have to be careful doing it too. Yes, we can look at the meteorological patterns and see what's similar, but it doesn't guarantee the same outcome.
Dry air.
Very dry. Now, what about animating that?
But ooh, hold on.
Are you frozen or are you just really still? Okay, there you go. Yeah. So here's the deal. Go back, Zach. Where you need to be concerned is those really dark greens. So go back and look. Wow, look at the -1. Yeah, it seems to be glitching a lot now. All right, there we go. So moisture return is well underway. Look at how it takes a long time to get to us, and we have that skinny, narrow tongue of moisture. I've seen this before. I'm not saying that it won't bring severe weather, but I don't believe that it's going to be widespread tornado potential. I just don't. See the darker greens though? Look at Shreveport at 67. That's a big difference. And look at that deeper moisture that's going through New Orleans. Yeah. Now that's some juicy air right there. Yeah, it gives you an idea. All right, Zach. Well, I think we can sum it up. Go back to the hourly timing. Yeah, so here's a good timing right here. Severe storm start timing. And that shows you that we have that potential for severe weather from 6 a.m. to 9 a.m. That's the time window, meaning the earliest onset would be 6 a.m., the latest is 9 a.m., and then anywhere in between. The earliest onset for the Fayetteville area is around 8 a.m. and goes until about 11 o'clock in the morning that it could be moving in, and then obviously 9 a.m. to 1 p.m. So what you're seeing there is the time window. I think we do get downgraded. I really do. Looking at the latest instability. So, yeah, it has moved up. Earlier, it was looking like, Ava, that it would be in the afternoon and early evening. That was last week. Now the system's a lot faster. Go to the risk, Zach, and you can show what's going on. David, are we still frozen? I don't know if we're still frozen or not. Yeah, so I don't know. I think we might still stay in the slight just because of the line that comes through, and I don't think they're going to change it. But I wouldn't be surprised if they take that marginal, expand that eastward a little bit.
Yeah, I think so too. And we've been talking about, um, you know, if these storms come in earlier, the severe storm potential will not be as high.
Yeah.
The instability is not going to have a chance to form.
But you can get instability at 5, 6 in the morning, 4 in the morning. Just think about that Springdale tornado and think about Cincinnati. But this is a totally different kind of thing where it doesn't show the instability, you know? but it could always return faster, and the low level jet could be underestimated. It could. So that's why you can't let down your guard.
Yeah, I think so. Yeah, so yeah, timing Tuesday morning. I think by the afternoon, pretty quiet, but there is still that potential, a surprise or two as that low pressure area, this is the center of it is near us, but we saw the wind profile. It didn't look very favorable.
No.
So I think there's a lot of uncertainty here still.
There still is, but it's starting to get a little clearer in terms of the lack of instability.
Yeah.
Oh, hey, Caden has a question here. Go back to some wraparound. Do the 3-day snow totals. Let's see if it shows any.
Oh yeah, good idea.
I don't think they're going to be slick because temperatures are going to be above freezing. They're going to be basically marginal. The temperatures are going to be right around freezing. You'll see, here's the kind of snow that you'll see. It'll probably like accumulate on like your car hood and your windshield, and that's about it. Yeah.
All the models have snow, but
I believe it. It's a strong system. There's a lot of energy. Matter of fact, let's do this here real quick. Let's show you the type of system that we're dealing with. I'm going to zoom out here a little bit. I'm going to show you the national view because this system just deserves to be seen from a wide view. So we'll start off with the 850 wind. I'm going to add this to the stage here real quick, Zach. I'll scroll down here a little bit. So here's the 850 millibars. Look at that. That is one heck of a low-level jet. Man, that is intense. 50 knots, 60 knots. That's incredible. Let me zoom in a little bit. Let me get to regional. There you go. Now you get to see it. Wow. That is insane. So the low-level jet on Tuesday morning, early morning, is going to be something to see, Zach.
Yeah.
Wow, you're going to see those clouds moving along big time. And see, that is a concern. That's a lot of energy. We look at the 700 millibars, and you can see that it's, here, we're going to go back to single image. All right, so there is 700 millibars at 6 a.m., and here's 500. Just a massive trough. I mean, this is a big system. Look at that system. Wow. But notice how we basically, we don't have any type of turning of the winds with height at all. We click on this and we look at the sounding, and it just doesn't have any surface-based instability at all. You're not going to get tornadoes with that. You'll get some elevated thunderstorms. You'll get some heavy rain, but that's about it. Look at the NAM 3 kilometer. Same thing. Just an intense, impressive system. So if we had, here's the deal, Zach. If we had Cape, like a lot, if we had Cape, we would have some pretty intense storms.
Yeah, that'd be an issue, ain't it?
But here's the NAM 3 kilometer. See, we have elevated instability. So remember, if you were a hot air balloon and you were rising, you would rise right along this dotted line. This is called a partial process curve. And you go all the way up to about 10 kilometers. In fact, the equilibrium level is, it's up there. Equilibrium level, it's about 10,000 kilometers. 10 kilometers, not 10,000. Oh, yeah, that is true. So we do have the potential for some damaging winds. and there could be some wide damaging winds because all it's going to take is a little bit of that downward motion to translate to the surface. So there could be some damaging winds. There's no doubt about that. Yes, the Cape could change. I just don't really think that's going to be a possibility. But I do believe, yes, you can. I mean, look at this. This is 850 millibars. If we go to, I wonder why they don't have 925 on here. I wonder if this one does. This one does, 925. So the 925 millibar winds are 30, 34 knots. They're pretty strong, but and you could get some downward translation of mixing of the surface, the winds at the surface. So there could be some strong winds, but that's kind of what we're looking at.
And I saw Alex Hall had a comment about non-thunderstorm winds. Those are going to be whipping too.
Oh, you should show that. Go to the HRRR and do the wind gusts.
Yeah, we were showing it last night, and the graph was showing like 56 mile per hour wind gusts. So yeah, let me show you that.
While you're doing that, so does anyone see an outbreak Tuesday? I think there's going to be a couple strong tornadoes. I don't know necessarily about an outbreak. It all depends on storm mode, but I think there's going to be some isolated cells, but not many of them. Destructive winds, that's always a possibility. Reed Timmer didn't like his chase from Oklahoma. I mean, come on, it was very limited instability, but it's still cranked up. So this is the NAM. So that's nearly 50 mile an hour winds there, and that's not even with the thunderstorms. Yeah, there you go. That's nearly severe, and then the line comes through. What about doing the HRRR? 85 mile per hour winds? That's not happening.
I didn't say that.
I know. Now this always goes overboard. We might need to redo this scale too, Zach.
Yeah, need to redo all of them.
Yeah. Is that as far as it goes? It gets real glitchy, man.
Yeah, it's because like the bar will go to the end, and then when you go another step, it'll go to like the very end. It'll just jump.
Yeah.
Yeah, so it gets kind of weird. Yeah, Edward, I was talking about the criteria for destructive winds, and I was saying that it was over 80 miles per hour.
Oh, yeah.
Considerable was 70, and yeah, it's all good. Edward, no worries. But yeah, and these are just the winds. Wind gusts 45, Fayetteville 43. Some strong winds.
It's a strong system. There's no doubt about that. No.
Got the graph too. And then look at these winds behind this system on the backside of it. They're going to be cranking, but out of the northwest. And that's going to usher in some cold air. So we'll be waking up Tuesday morning. It's going to be feeling like spring. But then Wednesday morning, that's going to feel like winter.
Yeah, that's craziness.
Yeah, big system.
Yeah, there could definitely be 55-mile-an-hour winds from this, and there could be wind gusts that are severe. There could be non-severe thunderstorm wind gusts.
Yeah,
Should we share this real quick, Zach? What do you think?
sure. The good old fire.
Yeah.
There it is.
So we got 54-mile-an-hour winds at 6 a.m. 54, 51, 40. Pretty impressive winds there. Well, I think that about wraps it up. But it is Severe Weather Awareness Week, and tomorrow's topic is flooding. And I just want to let you know I've got some special treats for our viewers. Got some Weather Call Next Gen free gift cards for a year. And I'm going to be giving some of those out tomorrow. And so next time we do a Facebook Live, we'll tell you how you guys can get those gift cards. What do you think of that, Zach?
Great. It's a great program.
Yeah.
And we always talk about Weather Call Next Gen because it's polygon specific. So you won't get a bunch of notifications for storms that aren't going to be impacting you. So it's good to know. And they do special notifications for the different categories of severe storms. And they're all, you know, they'll call you, text you, right?
Yeah.
Really good. Really
And
good.
gives you the all clear too, which is important. A lot of times people get in their freighty hole. And yeah, we've got some special gift cards. So we'll do that, and we'll do that tomorrow. In 10 minutes, it'll be today.
Yeah.
All right, guys. Yeah, of course it alerts. Not only does it alert for a tornado warning, but it also call you and let you know a tornado's on the ground. Yeah. It's true. It's true. So the winds for the storm add on to the non-thunderstorm winds. You can get a mixing down, but remember, you have to have a coupling of the atmosphere. And it looks like we have a temperature inversion that will prevent the translation of downward motion from those storms. So there will be a little bit of an added addition, but it's not it's not an inverted V sounding, if that's what you're looking at. You have a big time inversion, which will decouple the atmosphere. Oh, hey, we still got 500 people on here, Zach.
Yeah.
And I think it's a good time. Let's do the QLCS graphic.
All right. Let me load it up.
And we'll bring this up full.
And you can take over.
Just kind of step through and I'll tell you when to advance it. Oh, you're going to like this graphic. I spent a lot of time on it. I think it's totally done. There might be a few things that I need to do yet. But as soon as Zach brings this up full,
we've got it.
Oh, yeah. All right.
Should we go like this?
Nah. Yeah, you can. Yeah, you can do that. All right. So what is a QLCS? A QLCS stands for a quasi-linear convective system. It's just a fancy word for saying a complex of a line of storms, not a perfectly solid line either. It's got some breaks in the line. So let's kind of tell you how you can determine tornado potential looking at a QLCS. Okay, Zach, you can advance it. So QLCS stands for quasi-linear convective system. Within this line, you want to do what's called the 3 ingredients method. So you have the first ingredient is you want to find a balanced or slightly shear dominant area of the UDCZ. Now, the UDCZ is known as the updraft downdraft convergence zone. This is an area along or ahead of the thunderstorm line. And sometimes it's just a little bit slightly behind the thunderstorm line, as you'll see. So that's the first thing that you want to do, is look for that, what's called updraft, downdraft convergence zone. There are 3 regions within this updraft, downdraft convergence zone that you want to look for. There's one that's called cold pool dominant. That's the least likely area for tornadoes. There's shear dominant, where you can see tornadoes, but it's not as likely. But the most likely area is under the balanced area. So this is where you have the UDCZ kind of right on the leading edge of the storm line. Now, why is this important? Well, as we get down to the QLCS level and ground level, next you want to look for what's called the 0 to 3 kilometer bulk shear. I told you about this. The 0 to 3 kilometer bulk shear has to be 30 knots or greater along the UDCZ. Now, line normal means that it's perpendicular to this. So if we look at what that is, 0 to 3 kilometer bulk shear is you have a wind at the surface and you get stronger winds as you go up into the atmosphere. And what that does is that creates a horizontal shear rotor. This is known as environmental vorticity. So the environmental vorticity, I got to stop real quick, Zach, and give a shout out to Jake Fury. What up, my man, Fury? Good to see you on here, man. Oh, we had some good times. He was the audio operator. I saw that out of the corner of my eye, man. Megatron radar. Love me, Dan. You got it. Megatron and then Megadeth as well. All right, so back to the environmental shear rotor. And then on top of that, you have what's called the cold pool. Now, the cold pool is an area where you have cold, rain-cooled air that's descending behind the storm. And as it gets pushed ahead by the rear inflow jet, you're going to get what's called a cold pool rotor. Notice how now these rotors are spinning. One is spinning in a clockwise direction, which is the one to the right. And there's the one on the left, which is anticyclonic, which is spinning, or cyclonic, which is spinning clockwise, okay? So that is the environmental shear rotor and the cold pool rotor. Now notice how the cold pool rotor is spinning faster. So this is known as cold pool dominant. And the reason it is because as the thunderstorm goes up, it's going to tilt rearward. So if we look at the characteristics of the cold pool, the system's cold pool rotor is stronger. It spins faster than the shear rotor. So those updrafts tend to be weaker and rearward leaning. So you don't have tornado development as likely along the cold pool. The next thing is let's look at the shear dominant region. And so with the shear dominant region, you can see tornadoes, but it's still not as likely. So this is where you've got the shear rotor now that's actually stronger than the cold pool rotor. So as the cold pool comes in, it's kind of not, having constructive interference. It's actually fighting it. So now you'll have an updraft that's forward leaning because as you can see, the shear rotor is spinning faster than the cold pool rotor. So what that does is that takes those updrafts and has them slightly forward leaning because the shear rotor is spinning faster, and tornado development is possible, but not quite as likely. Okay, so now the next thing is the balanced region. So remember what Alex Hall was saying, how you want it to be balanced. This is the most likely area for tornadoes. So what does this mean? Well, that means you have the shear rotor and the cold pool rotor, and they're spinning about both the same speed. So if you have that cold pool that comes in, that gets actually tilted up into the vertical because they're spinning the same speed. So now you're going to get the system's cold pool and shear rotor that spins at the same speed. And those updrafts tend to be vertically deep and upright. So this means that constructive interference is maximized. So this is your most likely area for tornadoes. So you have this horizontal vorticity stream that's coming down from the storm, known as the rear inflow jet. And as that rear inflow jet gets tilted into the vertical, it starts to tilt and stretch. And remember, your updraft is vertical, straight up. But you can only have that with 0 to 3 kilometer cape. And then that leads to the development of your tornado. So it's the balanced region when that cold pull rotor and the shear rotor are spinning at the same speed. That's why we look for the 0 to 3 kilometer bulk shear to be 30 knots or greater. And so there's your most likely area for tornadoes. So we go back to that 3 ingredient method, Zach, and we've got number one, you want to find a balanced or slightly shear dominant area of the UDCZ, which is the updraft, downdraft convergence zone. You want to find the line normal 0 to 3 kilometer bulk shear, which is equal to or greater than 30 knots. Remember, if it's not, you're probably going to have cold pull dominant. And then the last thing is you want to look for surges and bows along that line of thunderstorms. Now, that QLCS that you see on the screen right there, guess what storm that was? I'm going to see if people can know. We can compare and contrast. Zach, go to the very beginning of the graphic. Go to the very beginning. Yeah, and then hit it. Hit one more time. Nope, not correct, Edward. Yeah, stop it right there. Nope, not Springdale either. Close. Look at where that storm is. See if someone knows. Nope, not November 4th. Nope, not March 30th, 2022. Nope, not Cincinnati, because that was a supercell. Nope, not Joplin. I'll make you a deal. Whoever can get this. Oh, Shayla. Cave Springs, but you have to give me a date. You can't just say you can't just say the storm. You got to give me the date. It's not April 1st, 2024. Got to give me the date. It's not Memorial Day. Nope, not Decatur and Rogers. Zach, do you know the date on this one? Nope. This
No.
is a good one. We're stumping some
Yes,
people.
but I don't know.
I'll give you a hint. Shayla, she was right in terms of the location. Nope. Got to give me the date. You can't just name cities. But Rogers was impacted by this. Oh, Kathy B with the win. October 2019. October 21st to be exact. 2019. That's right. This is the 31.4 mile, 1.5 mile wide EF2 that came through southwest Benton County and went all the way up to Beaver Lake. October 21st, 2019. You still did good, Shayla. You get a I'm going to give you a free weather call subscription for a year. So she wins the first gift card. I will reach out to you tomorrow. Yep, October 21st, 2019. And this is interesting, Zach, because bring it up again. Hit the button again. And keep going when we do the different regions. Okay, stop right there. We did not know as much about tornado potential and QLCS tornado potential as we do now. So there was a time when we were thinking the River Valley was going to be worse. And I know some people called me out on that because in the day, it was looking like the River Valley was going to be more likely to see tornado potential. I mean, and it wasn't. It didn't come to fruition. It was the river valley that was not having the storms. We didn't know why. Now we know why. It was cold pool dominant. That is the archive of the line. That is the actual archive. That's a radar capture of it that I cut out. However, Zach, we can bring it up. Let's do it. I'll show them. Now that we know we can isolate parts of the line that don't have tornado potential, that's going to make a big difference in forecasting tornadoes with QLCSs. But one of the things that you have to have is 0 to 3 kilometer cape. That's important too, because that's where you get that tilting and stretching that happens of the updraft. Mid-south. Central Mississippi, mid-south. I can't find it. Hold on just a second. Aha. That's okay. We'll do Southern Plains. Do Central Plains. Here we go. Central Plains is a good deal. Now, there's a big difference between this. Cold Pool, a Marvel weather superhero that kills tornado potential. Or it could help it too, depending on if the cold pool equals the strength of the shear rotor. All right, Zach, I'm going to present this real quick. This is the MMM image archive of October 21st. And look at the timing. Here we go. Pink. Pink has arrived. So look at all these cells. And then those cells are looking pretty impressive. And then they get into the river valley and they just die. And we didn't understand it. But the cold pool was out ahead of it. You couldn't see it on this. Let's see if I can zoom in on that. I've got the real good archive too, but we'll just deal with this. So anyways, there's the line coming through. This is all balanced all along here. This is where it's shear dominant, so there was still some tornado potential, but this is all balanced. And then look, you see the descending reflectivity core? There it is right there, and you can see that the rear inflow jet is actually coming into the area. So if I do this, if I go to Tornado Archive and bring up October 21st, and we look at this, of course it's not going to be on there because you got to do October 20th. And then after this, Zach, I'm going to go to bed. But here's the tornado. Look at that. That's a long track. Southeast Siloam, all the way through Rogers. Will, I don't think the radar at XNA would be a good position to have it, honestly. We're doing some research on that. I don't think that a radar at XNA is going to be good because it's kind of down in a valley and the terrain would shade the radar beam quite a bit. Oh, yeah. You got that right, Hayes. And you were on that storm like a fly on stick paper, man. You were on that. That was amazing. And we kind of knew it. But anyways, there's a look at that Siloam Springs. And I want to go to the environment here. We can look at the environment. Let's look at the pink. So here are the photographs. If we load them. Let's see if it loads. Maybe not. Pink? What's the matter with the pink? Environmental data is off. What? Ow. Look from the menu on the left. I am. Huh. Well, I guess that's not going to load. Guess they don't have the data. I don't know. That's weird. Normally they have the data in there. Well, Zach, what do you think? I haven't heard you.
Is the day 2 outlook out?
Oh, it might be.
Saw a comment about it. Oh, it is. And we've got some changes. What do you think happened, Dan?
I think they probably shifted the slight farther west, and then no, actually, I think they took the marginal, and I think they dropped that down a lot farther south. Let's see.
All right, let's see it. Drum roll, please.
Aha! Marginal changed, nailed it. Marginal, and then they shifted the slight south, and then the enhanced risk. So we can look at the individual risks.
Yeah, let's do
I
that.
bet you our tornado potential is probably 2% over us. Yep. 2 and 5 in the river valley, a little more instability. And there is a hatched area for tornadoes. Surprised that doesn't go down all the way to New Orleans.
Yeah, that's weird.
I wouldn't be surprised if that does. Pink.
Now here's the wind.
Yep. Now I want to see the marginal in Madison County, and then there's the large hail risk. Hatched area, I doubt it. For hail down south, no, nope.
So that's it.
There you go.
Day 2.
We'll go to 10 hours, past 6 hours. And we'll go to
And that was Patrick who let me know about that. Yes, appreciate that, Patrick.
So here's a look at, just to let you know. Whoops, share this tab instead. So this is the meso-analysis archive of October 21st, 2019. And look at all that 0 to 3 kilometer cape that was over us. So a totally different story than what we'll see Tuesday morning. Look at how that just drops off. But pretty impressive there. If we go to, this is going to be interesting, 0 to 1 kilometer storm relative velocity. You're just going to see this is off the charts probably. Yeah, look at that, 500. So not only did you have a lot of wind shear, but you also had a tremendous amount of low-level instability. Look at that. That's 0 to 1 kilometer. So that shows you. And then look, it got up to 600. Pretty impressive storm. I'm just saying we're looking at October 21st, 2019, not to compare, but just to look at what those parameters were like. So, all right, Zach, I think that's it, man. We're going to shut it down.
All right. Well, yeah, that's it. And we'll do more updates as we get towards Tuesday. We'll probably do one tomorrow again, right, Dan?
Yep, we'll definitely do one tomorrow. Um, Hayes says tornado nightmares are the best. I had a tornado nightmare a couple of days ago. They're so real, man. You're in your house, and I could hear the siren going off, and then I could hear the tornado like chewing things up. And we ran down in the basement, and then I woke up. I was kind of upset. I wanted to see what happened to the house with it getting hit, but it's pretty scary though. It definitely is.
Well, all right, 12:13 a.m. I think we're going to sign off on this Monday morning. So,
That's a wrap, Zach. Thanks for all your help, man.
yeah, of course. Yeah. And there is a live weather blog on KNWA.com. You guys can go and check it out. We'll be updating that tomorrow, too, some more. And yeah, hope everybody stays safe and have a good night.
Well, hold on, Zach.
You got it.
Yeah, I was just going to show. So this is the weather blog right here. 3 hours ago. Oh, you could probably put the new risk in there real quick, huh? Yeah, good stuff, man. Updating them so you can see. All you got to do is just go to the home page, and it's just right there, weather blog. All right. See you, Zach.
All right. See you guys.
All right, cool. Hey, thank you so much. Have a good one. Bye.